Hi scientists, this is the video for the melt and freeze full day. So you should have this sheet that looks like this. You need to make sure that your name is up at the top here, if you haven't done so already, and that also your page numbers are on here. Your page numbers should go down to the bottom on one side, and over on the side here, on the other side in those circles. So we see everything that we need to know about melt and freeze. First off, if you haven't done so already, we need to fold this. So we have to fold this in so that this kind of goes in this middle of these center circles. Then we meet our paper right here. So we are going to do our melt side first. So on the left side where you have your name, we need to write the word melt. Then we need to come up with an example of melting. So it's kind of a before and an after picture. And these pictures are actually going to be our particle dots. So we have to think about what state does it start as, what state does it end as, and how do you draw the particles? Do they touch the bottom? Do they touch the top? Do they touch the sides? Do they touch each other? And how jam-packed are they? So above this box, you should write the state that it starts at. And down here, you should write the state that it ends at and draw the particle dots. Press pause to do this, press play to begin. Then we're going to do the same thing over here on this side, and we know that this side is freeze because when I open the door, freeze occurs. So I'm going to write freeze up there. And we need our particle dots again. So we have to think about what state does it start as, what state does it end as. Write those states on the line and then draw the particles. Think about again, does it touch the bottom, the top, the sides? Do they touch each other? Are they squished? Are they spread out? All those things. Press pause to do this, press play to begin. All right. So now we're going to go to the inside and we're going to think about what they have in common and about what they have that is unique. So we see another double bubble. We saw this with our mass and weight. And these information bubbles are going to be filled out using your notes, which is page 5 on the front is melt, page 6 on the back is freeze. So if you haven't referenced those yet for your particle dots on the outside doors, you should get that out. So, in the center, these are things that they have in common. So we have to think about what are the two things that both melt and freeze are, and what do they have in common. So we're going to say they are both, and it's two words. Then we have to think about one more thing that they have in common. And maybe if you look at the front side, you might understand what else they share, what else they have in common. What do they both involve? And we're going to say they both involve blank and blank. Press pause to fill out their common bubbles. Use your notes 5 and 6. Think about what words you've used that are the same. And press pause to do this. Press play when you have to begin again. All right, so now that we know what they have in common, now we're going to talk just about melting. So over here, I want you to talk about, do you have to add energy and heat to make an object melt, or do you take it away? Press pause to do this. Press play to begin again. Over here, for the speed, does it increase or decrease? Remember, increase means that the particles get faster as it melts, and decrease means they get slower. So does it increase or decrease? You pick the right one. Press pause to do this. Press play to begin again. And last but not least, we have particle distance. Again, does that increase or does that decrease? We need to think about, this is a harder one for kids, if the particle distance increases, if I'm spreading out, if I'm increasing the distance between them, that's an increase. If I'm coming together, the distance between them is decreasing. Press pause to think about what happens when we go from solids to liquids, and press play to begin again. Okay, now we need to fill in our sentences. An example of melt is, so you write down an example on this line. I'm going to use melting an ice cube. You cannot use that. You need to come up with your own example. So I'm going to say an example of melt is a melting ice cube, because heat is, whatever you wrote in that bubble should go there. Causing a, this is the first state that it's in, solid, liquid, or gas, turning into a, this is the second state. Where does it end? Solid, liquid, or gas. Press pause to fill out your example. Press play to begin again. So we should have all of melt done. We should have our in common done. And now we're going to do our freeze. So we need to think about energy and heat. Again, is it added or is it taken away? You're not going to write both. You're going to use your notes or use what you know. Press pause to write the correct answer in my freeze, energy, and heat. Press play when you're ready. Same options for speed. Does my speed when I freeze increase and get faster, or does it decrease and get slower? Think about liquids to solids. Do they get faster to do that or slower? Press pause to do this. Press play to begin again. And last but not least for our bubbles, my distance. Does my distance increase or does my distance decrease? When I freeze, when I go liquids to solid, if my distance increases, that means they are spreading apart. The distance between my particles or my hands is increasing. If they are coming together, the distance between them is decreasing. Press pause to fill this out. Press play to begin again. We need to now have our example sentence again. An example of freeze is, think about something you can freeze. I'm going to choose making an ice cube. You cannot choose that. So an example of freeze is making ice cubes, because heat is whatever you've done there, causing a, what state does it start in, turn into, what state does it end in? This is my starting state, this is my ending state. And again, if you're like, I'm not sure about this, remember our three states are solid, liquid, and gases. And you can have this right here. Look at your particle models right here, because that will help you fill out these two. So we should have our whole thing filled out. So right now, we need to do one last thing. We need our reds and our blues. Anywhere that you have written our red words, I'm going to make a little key down here. You don't need to make that, but this will help you. So any place that you put increase or added, you need to box and shade in red. You can shade the whole bubble, or you can box and shade just the word increase or just the word added. But your added and increase words need to be boxed in red. Same thing for decrease or taken away. These ones need to be boxed and shaded in blue. Again, if you want to shade in the whole bubble, that's fine. Remember, when you shade, we still need to be able to read your writing. So if you shade too dark, we won't be able to read it, and then you can't get credit for it. So you need to make sure you shade light enough where we can read your writing, but also dark enough so that we can see it as shaded. If you have questions on this, you're going to first use your notes on page 5 and 6. Then you can ask a teacher. Remember, scientists, you can't ask each other because this is a graded assignment. Good luck and have fun.